Chapter 11, Sample Problem 13. A bullet of mass m is shot at a hinged rod near the end of the rod. The rod was initially at rest and has a moment of inertia I about an axis through a hinge. The bullet is fired at various angles theta to the rod, as shown in the top views above, with initial velocity v at an angle d from the hinge. So the only thing changing is the angle. And we are asked to rank the magnitude of the angular momentum about the hinge of the rod. So a lot of this actually ended up being irrelevant, but it's going to come back to the idea that even particles moving in a straight line about some distance such a particle still has an angular momentum, whose magnitude is given by r perpendicular times p, where r perpendicular is the moment arm of that momentum, in the same way that we have a moment arm for a force. So if we look at, say, case A, our moment arm is that, and our shortest possible distance from the moment arm to the pivot is this. Looking at case B, we have a line of action, which is, in this case, purely vertical, and therefore the rod itself is the moment arm, so that's nice. If we look at case C, our line of action is this, and so our moment arm is this. And finally, if we look at case D, we have this, and so our moment arm is this. And in fact, we can probably look ahead of time and say, well, which of these is going to be greatest and least? B is definitely going to be the greatest, because it is, in all the other triangles, it's a hypotenuse. So our answer is definitely going to have B as larger than everybody else. And then we can almost visually inspect it, that it looks like it's going to be A, and then it's going to be C, and then it's going to be D. Perhaps the right and best way to do that is to actually draw the triangles in sort of a more traditional thing. So we'll have, for A, we might have, we have the same hypotenuse, but a 45-degree angle, I guess 60-degree angle, so 60, and we're interested in the far side. For case B, it's the hypotenuse, so we said that has to be longest. For case C, that's the 45-degree angle, and we know that for the same hypotenuse, we'll get a longer. And then for case B, we'll have a 30-degree triangle, so we know that the far side is large on a 30-degree triangle. So we're in, as we said, the case B greater than A, greater than C, greater than D.